Oh, did I have it? We are
Oh,
live.
we are.
Yes, we
Hello.
are. I challenge somebody to prove we are not live. We could be AI.
We could totally.
Yeah.
We're low enough resolution in this format that
Oh,
That's an interesting point. I believe it's going to get to that. It's going to get powerful enough to do a true
talk show or something.
A true max headroom that's not all plastic.
That's who I was trying to think of. Yeah, max headroom. And I remember rolling on the floor laughing at that show when it came out.
Oh, I loved it when I was a teenager when that showed up in Australia, and even then it had already been going for 10 years. Just these short little snippets, right? They were like 5 minutes long or something.
Right.
And the MTV show in Australia, when it launched in Australia, was playing bits of Max Headroom in it.
Right.
Yeah, it was fun.
So very cool.
So for those who are young or not from these parts of the world, Max Headroom was the world's officially first digital puppet. When computer graphics got good enough in the late 80s to have the form of a presenter on TV, but generated using very rough 3D graphics. You can look it up on YouTube.
Right. Well, you remember the old Star Trek episode where they had a puppet on the Star Trek, the one with Tranya? We really should.
I don't remember that. I'll have to go back and try and find that.
Yeah.
My favorite was Holly from Red Dwarf.
I didn't watch Red Dwarf.
Bill, you've got to go watch Red Dwarf. the best sci-fi sitcom ever.
All right. I'll check it out.
Very British, which is probably, as an Australian, is probably why I understood the humor pretty well. But but Red Dwarf was hugely popular in the States. A lot of people in our Discord, I'm sure, have seen at least some of Red Dwarf. It's
right. Well, wasn't Babylon 5, wasn't the guy in Australian acting like an American or something like that?
Oh, I don't know about Babylon 5 actors. I did watch Babylon 5 with my older brother David. Was a huge Babylon 5 fan because he's a graphic artist.
Okay.
That's been his profession. He still does that a little bit on the side now. He's moved on to doing other things, like he's a pastor of a church. But he and I used to watch B5 together. He was his favorite computer until he was basically forced by performance gains to move to PC, or maybe he's been using Mac for years and years for graphics. But before that, he was an Amiga 1200 user. For his Amiga 1200, he just kept upgrading it, tricking it out with all sorts of. It was a great computer. And and like they're unaffordable and unobtainium now, but if I could get an Amiga 1200, that would be probably my one of my top choices, up there with a C128. Would be an Amiga 1200. They were really great computers.
Right.
And totally, there's so much out there that can be used to speed them up and add power and all sorts of things. Anyway, sorry, going off on a tangent there. Still waking up, I guess.
So cool.
We're talking about USB. You've been doing a lot with USB lately.
Well, I've been on a journey, USB-C journey, and it's like one of those things like, I don't want to learn it. Okay, I'll learn it.
It's complicated. When USB 2.0 came out and was brand new, and we were like, how can you send 480 megabits per second over a cable
wire that you can't control? Yeah,
right. And there were people. I was at Altium then in those days. There were guys on the development team working on Nanoboard 2 and Nanoboard 3000 hardware design, and some of them were working on firmware and IP cores for FPGAs for supporting USB 2. and one of them bought the book. There was this one book, I forgot the name of it, but there's links to it on the USB Trade Federation's website. They've got the resources and stuff you can download. But they have suggested reading, and this one book's, it's like this thick hardcover, and people were constantly trying to steal it off this guy. His name was Ben too, actually. He was funny. He was a funny guy and a really good C++ developer. I asked him once when he was new at Altium how he liked coding in Delphi, and he said, "My IQ's dropping by the second."
Well, was he a Borderland fan or something, or?
No, it's just what he may have been. He may have been.
Yeah.
But yeah. I kind of feel like actually didn't that come originally from what was that movie with the dueling banjo and guitar, Deliverance?
Yeah.
Wasn't that from Deliverance? Might have been from Deliverance. But you're saying Borderland. Okay, whatever.
Right. Yeah. So let's see if I can show my little setup here that I've been playing with this week. Oh, there it is.
Oh, that's cool.
Let me zoom in real quick here.
That little monitor, I've been looking at those. I haven't pulled the trigger to get one because I don't have a good reason to have one, but I might soon with some of the work I've got coming up.
So yeah, so here I have my USB monitor, but here I've got a programmable, let's see, you can't see my same finger, programmable sync source. So what I've got is the ability to, let me switch cameras here.
So wait, the little Cypress thing is a USB monitor tool,
right?
Okay, so how long have you had that? Because if it's branded Cypress, it's certainly before their Infineon acquisition. And Cypress, before FTDI hit the market, we're saying this before we went live. Before FTDI sort of took over the easy to do USB kind of market and USB serial ports and all that, Cypress was the big deal with their easy USB microcontrollers.
Right.
Was this from that era, or is this?
I believe so, because the website kind of jumps to, they link to a missing website, then you go to Infineon, then the software you download doesn't work. It says, hey, you need a new version, but I can't get it for you, and it crashes. So I went to the engineer community forum, and they said, use this version here. So I had to use a different version. You download off a forum thinking I just wasted my money, and it actually worked. So it's obviously the software got kind of dropped between Infineon and Cypress is my opinion.
Yeah, I guess they just don't want to encourage people to keep using the first or second generation easy USB parts.
Right.
I'm still getting that staticky sound.
Well, okay.
But it's less than it was before you switched mics.
Very good. And you're still distorted a little.
I'm talking too loud. I'll just lean back and talk quieter. I should probably be resting my voice anyway. So, so this is cooler.
Yeah.
Wait, that's ST. That's ST micro.
Oh, well, this is a different thing now. So the programmable current sync, the thing that acts like a, hold on, let me switch my camera here real quick. The thing that acts like when you plug a USB device into a charger, for example, this has an upward facing port, the device, and the charger has a downward facing port. So what I've done is on the upward facing port, the current sync, the thing that you're going to charge is this STUSB 4500 board that I showed. It's just a little tiny board there. I'll point it out real quick.
Oh, on the, sorry, spam. That's the problem when you get a Skype number to use that as your interference for business. Suddenly you start getting spams on Skype all day. I'm starting to regret my decision, but anyway.
So
there it is.
the SUSB board is this little tiny thing here with actual terminal block, and that's plugged into the protocol analyzer.
Now that protocol analyzer, being the age that it is, only goes to it supports USB 2.0 and on the go, I assume.
And it supports USBC PD protocol, the power distribution protocol, where we actually negotiate what. Hang on, let me switch my camera.
So it is a newish device if it's USB-C type.
It is USB-C, absolutely. Okay. So what I've got here is the ability to ask for voltages. So I'm going to change this thing here that says 9 volts. I'm going to say, well, you know, I'd really like 20 volts. Where'd it go? Oh, okay. So now it's going to screw up.
Did it lose connection?
And this is why programmers hide when I'm around. Yeah, I'm stuck in a loop of death. I can't demonstrate what I was going to demonstrate here. So programmers, don't ever write code like this where you just go, it's an error, jump to error, it's an error, jump to error. What's wrong with you? What's wrong with you people? You know? Cannot open the USB. That's fine. Stop it. So,
well, they wrote the code. Oh, how many times should we retry this before giving up? I don't know. Just pick an arbitrary number. Make it 100.
Yeah. Yeah. Well, that sucks. What do you have to show while I work on this?
Well,
you have a USB analyzer.
Not a lot. Oh, that's my Fusion. Sorry, I'm waiting for them to fix my subscription. They terminated my account unexpectedly by accident, but they're working on fixing it. So I hope they get it done soon because I need to use it for some 3D printing stuff. Anyway, so well, your previous talks, the last few weeks you've been talking about USB. It reminded me of there's some really useful software out there, and it's kind of indispensable if you're going to write software and drivers, particularly if you're doing a custom USB based product and you need to write drivers for the operating system for the host. Right. You really need some protocol analysis. I was trying to get Wireshark to work because there was a version of Wireshark that would
Yes, you're right.
There was a version of Wireshark that would also capture USB packets, but I just installed the latest version today. I've got to keep doing this because I said it's only allowed to be used by administrators. So user account control keeps interrupting too. It'll only do it like, I don't know, 30 times. And then anyway, but in this version, USB is not listed here. And I don't know why. I thought it was because it couldn't find it needs a particular capture driver called USB PCAP, which I do have installed on this computer, but for some reason it's just not showing up in this version. So I wanted to show that today, but I can't. That would be preferable because Wireshark is 100% open source and free, and it can do anything. It is exceedingly powerful. I used to use Wireshark. I first found it when I was before I found it really like many years ago when it was a brand new open source project, and it was pretty powerful. When I basically left my pre-sales software role that I had at a startup many years ago and had just gotten back into electronics design, but somewhere along the line, I know where it was. I was teaching electronics at college in a place called TAFE at Meadowbank, kind of like community college, right? was teaching electronics and I was teaching computer networking. So I was looking for a packet sniffer to show the students stuff and to have some cool experiments in the lab where they could actually see what's going on in the network when they change things, and see the TCP protocol in action and DHCP. They could see the, you know, the broadcast, the request, the acknowledge. And that's how I discovered Wireshark. So that was in the year 2002 or 2003.
So I used Wireshark this week.
Yeah, it's really good.
So this week we troubleshot it, since you mentioned networking and digging in real deep. I had a customer that SIP registration was occurring for the phone, but an invite wasn't coming through the registered tunnel. And we traced it through the firewall, and the firewall said, I see the invites. We get to the inside Cisco router, and we had to do a capture on the router called not a span port. We did a mon capture command, dumped it to file, TFTP'd it out, pulled it into Wireshark, and the invites are gone. And the moral of the story is the firewall was eating the invites inside the tunnel, which means it was a layer 7 boo-boo. They were blaming the switch, and I'm like, the switch knows nothing about layer 7. It can't go into that conversation and extract an invite out of the SIP protocol. It can't. It's a forwarding table. That's all switch is. Packet comes in, he says, exit that way, and out it goes.
Right, yeah, so that's the weird thing about, and if it's a good firewall, it'll do that kind of stuff, right? It'll have that capability to peel back the layers and reach in and choke something that's buried in there if it understands what it is. And this is why hardware firewalls, which aren't really hardware, they're software, but what I mean is it's a dedicated rack unit with firewall software running in it.
Right.
They're actually up there with compute performance these days. They have to be, because they're analyzing a lot of stuff that's got to pass through very quickly. So yeah, why I like this comment. Wireshark has saved my butt several times as well. I've actually used it. I always had it installed. I just hadn't had it on this computer for some reason, haven't had to. But even throughout my career in EDA, there were various times where I used Wireshark to discover what was causing a problem with a license not getting activated for a customer, or, you know, and it was a way to find where is the communication breaking down here,
right?
And it's just, there's so much to it, and it's so powerful, like with all the filters you can do and everything. It's kind of daunting. But even just using it in a very basic way, it's super powerful. So what I'm looking at here is a similar thing, but just for hardware I/O. And this is a free version, like free cut down version of commercial software. But I found this 2 years ago when I was trying to troubleshoot some USB stuff with FPGAs. And this will do the same thing as Wireshark. It'll capture packets and filter them, but it'll do it at USB serial port network. This is just called Free Device Monitoring Studio. It's by some German company, and yeah, they have no knowledge of who we are and don't sponsor or anything. It's just the one that I found that you could actually get some decent information and USB packet capture, at least. Very, very basic in the free version. The commercial version costs a few $100 to get everything, I think. So if and when I'm launching a commercial product and need to do debug and driver development, it's probably worth spending the money on this, or figuring out how to get Wireshark working with USB. HHD make this. So what this was I was just selecting a particular USB port, which happens to be, let's see, let me start this again, actually. How do I do this? Empty workspace. I'm going to stop capturing. Stop. I just want to clear this out. Okay, so then it gives you a list of all the stuff that would otherwise be found in Device Manager. And here's the thing, this is Windows only software, this one. There's got to be things, there's got to be tools like this for Mac and Linux. Linux actually probably has more, just because it's all based on open source. I know there's a whole USB library that allows you to capture USB packets in promiscuous mode. And so there's probably a lot of different utilities in Linux that make this doable as well. But you basically just choose from the list that you would see in. So I could look at my webcam that I'm using right now.
Can you show us something get enunciated?
Enunciated.
Where it first introduces itself and says, "Hi, do you want to talk?"
Probably. Here's the problem. Like these devices are all enumerated already.
I said enunciate. I meant enumerate. I'm sorry.
I know what you meant.
Yeah, you get all the tokenizers broken.
So I have this DI that has USB port. And it's using, obviously, an FTDI virtual COM port because that's the device that disappeared from the list, right? I don't know how that might be one of the more advanced features that you pay for. Let me see. Let me see. CCC. Download or connect to new server settings. It could be one of these grayed out items like
okay,
pattern highlighting.
So what are you doing with USB that you're using this analyzer?
I wanted to see how this particular device is handshaking with the software that you install that comes from the manufacturer of this device, to see if there's any other way, because I noticed that if this is a USB virtual COM port, I should be able to interact with it as a COM port, using other software or even a terminal. And I wanted to see if they were just doing things with, if they had plain text commands or anything. Unfortunately, no. It's all appears to be, binary.
Yeah.
All right, but yeah. So
I got the USB-C working then.
That's cool.
Yeah. So let me know when we're ready to go back to that. But did you want to show more of your USB capture?
Yeah, I'm just starting a session here.
Okay.
And there's a lot of additional possibilities here for the commercial. So you can see all the stuff that is left out of the free version, but at the very least you can add packet views, URB view. I forget what does that mean? It means the URB view data visualizer decodes raw packets and control requests sent to and received from. Yeah.
And this is all just software. You're not using a hardware.
No, this is pure software. And so it's probably the benefit of a hardware is you will get the enumeration and handshake stuff. I think with a software capture tool, it has to enumerate in the host operating system before the capture tool can start looking at it.
It makes sense. Yeah.
So I'll just hit start on there, and I've basically done nothing. It's just like the device is connected and it's waiting, but it's in capture mode. So if I launch the software that, let's try and do something here. I'll go for Takamine and download that to slot 7. And hit yes. Then we see a bunch of packets appear. So I'll close that. So yeah, I mean, that's a whole lot of handshaking and data. And this is the basic packet view where it shows host and device sort of. It's just saying sending to the device to get the device in some sort of mode in order to receive. Sync reset pipe. So there's some USB standard command decoding going on here as well, right? And then this is a bulk transfer where this will be some device custom
ID or something.
Oh, it's a pipe handle actually.
Ah, okay.
Well, no, that's the existing pipe handle, but then there's some custom binary sequence to tell the device, hey, I'm about to send you. There's an acknowledgement. I notice whenever this device sends back to the software, it always starts with 1160. That's some sort of acknowledgement. And then, there's some plain text in here, like a name. And then this here is the plain text name of an impulse response file that's being obtained from the device or sent to it.
Wow, cool.
Right, so that's the basic packet capture. Very similar to what you get in Wireshark, right, with network sniffing.
Right.
And so this is the packet view, and this URB view is what shows you the contents of the packets. But beyond that, the filtering capabilities and all the other fancy stuff that you might need to really debug a driver that you're trying to write in software, you would probably really want the software that can capture and filter everything. So either Wireshark or the commercial version of this. So yeah, I can't do a whole lot with this. I've discovered since I was looking into it that, this device uses their own proprietary format for impulse responses and everything. So there's no point me wasting time trying to find a way to get my own WAV files into it.
Right.
It's just a waste of time.
Right.
But there it is.
Cool.
USB packet capture.
Now, do you know of any USB protocol analyzers that are standalone that are cheap, that actually has hardware where you could catch the enumeration?
Well, other than the ones you have on your desk right now, I haven't purchased any or used any in the past. So
right.
I'm sure there's plenty of them out there. Probably any semiconductor company like Cypress or now Infineon that makes USB chips has products for debug like that, but they could be, I guess they're usually going to be expensive. But that was the thing I really liked about Cypress.
Oh, they were great. Yeah.
All their stuff to get you going with development was actually like super cheap when you think about it. Like back in the day, if I was dealing with like the way it used to be, if it's, well, I guess my bad memories come from FPGA work that I did in the past, when FPGAs have always been expensive anyway. But it was like you couldn't get started for less than $1,000.
Hey.
You couldn't even begin. Like the software might have been free to download, but you couldn't get a JTAG debug. Like you get a JTAG debug cable, you'd have to buy the $400 Sega one.
Right.
Particularly for DSP chips and things like that, you'd have to buy expensive stuff just to get rolling.
Right.
And modern. That's something I like, that the modern low-cost microcontroller has also driven down the cost of development tools.
Right. So, okay. Well, I can show again, my analyzer is for PD, the power distribution protocol. Let me see if I can put that up now. And we'll try.
So you got it all rebooted and it's.
I do. Yes. I
good.
troubleshot it. Yes. All right. So here, this is the current sync. It's programmable. So I've got two things going on here. I've got the analyzer in the middle. Actually, I've got a little voltmeter in the middle too. And then I've got a programmable sync. And so right here, I have three proposals I'd like. I have the default, which is 5 volts at 1.5 amps. There's 15 volts at an amp and a half, and let's put in 20 volts at 3 amps, see if this thing's capable of it. And so I'll write to the device. Now it's successful. So here I'm going to capture a new negotiation. So let me clear data, and I'm going to plug and unplug it. Oh, look at that. Oh, I love it.
Oh, that's so cool.
I love it. So,
and it gave it 20 volts, 20.12.
Oh, like, you're jumping ahead. So here is our description of source capabilities. You can actually see it says that there. Let me even zoom in a little more here. Source capabilities, and it lists these data objects of things it can do. So here, for example, it says 5 volts at 3 amps is data object 1. Down here further is 12 volts at 3 amps. And here's 20 volts at 3.25 amp. It can't quite do 3.5 amps. But what is this? This is the power supply saying what it's capable of. So I bought myself a little 60 watt. That's if you do 20 times 3.25, you'll get the watt, 65 watts, I think, power supply. And I said, hey, what are you capable of doing here? And he listed those things. So then, and that's the downward facing port, DFP. That's the power supply looking down. And the upward good guy, he says, good CRC. Says, I understood what you said. I saw your 5 things, all those fields, and I agree that your CRC passed. Then he says, well, I'd like a request. I'd like position number 5. He says, of all of those different policies, I want number 5. That will allow me to charge my batteries the quickest. So the power supply says, hey, good CRC. What's that mean? It means he heard him, right? He's
an acknowledgement. Yeah.
Right. So, and then he says, I accept that that proposal that you said. Hang on, I'm trying to.
This reminds me of the class I used to teach in the Net Plus college class, and we had this main subject for one of the days was DHCP protocol.
Yeah.
I'm having flashbacks.
Right. He goes on port UDP and says, hey, I'd like ARPU has and I'd like that. And he boot peas an answer to him. Yep. So then he says, well, wait a minute. He says, okay, power supply ready. And look what happened to the voltage. It jumped to 20 volts in this column right here. So I just successfully negotiated 20 volts by programming first the current sync and said, ask for 20 volts. And then we plugged it in and the power supply said, here's 20 volts. Now, I finally understand USB-C, why to use it. This is kind of why I've started my exploration. I went to plug in one of my 2 laptops the other night. I had swapped positions. And I had to mentally go, when I held that power supply in my hand, is this the right power supply for my laptop? Just the fact it's a 2.1 millimeter barrel connector, I could screw up my laptop. And then I go, okay, it's not, it's the right one. But had it been USB-C, I would have plugged in and said, you guys negotiate.
Yeah, and then the laptop gives you a warning saying, well, I can't really charge off this, but I can slow down my battery's demise.
Right. Well, think about it. A laptop is a dual DRP, dual role provider, I think. Mm-hmm. And if you think about it, a laptop can be charged, or a laptop can turn around and charge something in turn.
Right. Especially USB, especially Thunderbolt and USB-C laptops The first one for a little while there, several years ago, Altium gave me a tiny MacBook Pro. I'm like, what am I using this for? But the only ports anywhere on the whole thing, the only holes in the chassis were Thunderbolt. So
Okay.
USB 3.0 and Thunderbolt. And you could plug the power adapter in anywhere. You could plug your phone in anywhere. And I was like, okay, that's the whole point.
Right.
Yeah.
Right. So I've been doing research for the Hackaday article on USBC, and I saw that Thunderbolt, which I don't fully understand yet. Maybe you can explain Thunderbolt, but in fact, I'll probably call it what's the other stormy word? Lightning. I'll probably call it lightning before it's done with. But I've seen where the vendors are having trouble being compatible with. I saw a thing that says Dell said it has Thunderbolt, but it's not, right? It's like they're not even supporting their own protocols consistently right now.
Yeah, they're different. So, and I don't really know it super well, but my limited understanding is the third generation of Thunderbolt, which is an Intel technology.
Right.
It basically is for putting either DisplayPort, HDMI, Ethernet, or PCI Express. And it could be up to, 4 PCI Express lanes even, right?
Yeah.
Depending on which generation, all over a serial cable.
Yeah.
Serial port. That's
5, 10, and 20 gigabit per second. Yes.
That's what Thunderbolt is, right? And they just it wasn't USB up to generation 2, but Thunderbolt 3, they decided, well, the USB Type C, which is USB 3.1 connector, the physical connector, and its signaling and signal integrity and all of that is capable of Thunderbolt 3. So we'll just make it use a USB 3.1 connector. And then they made devices to negotiate. Am I plugged into a USB device or hub, or am I plugged into a Thunderbolt thing? And so, yeah. So I was bitterly disappointed because when my first encounter with Thunderbolt was with that MacBook Pro, and I just assumed anything with a USB Type-C connector was Thunderbolt. And so I had this Thunderbolt dock that had all sorts of video outputs and USB 3.0 ports, and could deliver power to the laptop through it. And I connected it with a regular USB Type-C cable, and it didn't work.
Right.
And then I got a gaming laptop that had one port on the back that was USB-C, and I plugged in a Lenovo Thunderbolt dock, and it wouldn't recognize it.
Okay.
And I'm like, why? Why won't this work? And then I did my homework, and then finally realized, damn it, this laptop doesn't have Thunderbolt anywhere. I've been gypped.
Right.
I bought it because it had that one port on the back, and I made my stupid decision based on the pictures, not on a list.
Right. And USB-C is the connector, not the It doesn't imply anything about the protocol. It doesn't guarantee the protocols. It's a connector, is what USB-C is. Yeah.
Yep. So
yes, John Riney is saying PCIe over USB is just, and I saw the USB-C capabilities as a way to extend PCIe, which is just insane.
Well,
you can pump that down a wire through a connector into an infinite variation of receivers, as long as they're certified. That's
a weird thing too. Like PCIe itself is already serial, right? So they went from PCI to PCIe. Their means of going faster, oddly enough, was to go from parallel to serial, which is counterintuitive. But it's a lot easier to do really good signal integrity and high speed with a differential pair and cranking that as hard as you can. than it is with a whole bunch of traces on a board and through a connector next to each other where there's tons of crosstalk and
so put all your eggs into one basket and then watch that basket really well. Put all your eggs into the serial port and then SI the hell out of it.
So with Thunderbolt cables, they have to be able to cope with even Gen 3. They have to be 40 gigabits to aggregate bandwidth. That's over all the pairs. So the cable has multiple pairs in it.
Right.
And this was the other thing, like I was saying, this sort of what got me disappointed as well. Wrong drawer there. And this has improved since then, but at the time, this is a Thunderbolt cable. You see, it's got the Thunderbolt logo on it.
Okay, right.
And the number 3 that says it's Thunderbolt 3.
Okay.
Right? You could not get a Thunderbolt cable longer than this.
Right. Right.
It was not possible because, it costs a lot of money to make a cable that can take 40 gigabits a second and not have significant insertion loss.
Right.
So I realized too, it's like, because I bought some USB-C cables that'll do 5 gigabits a second. They'll work with a, external SSD quite happily that get pretty good performance, but they would not work with a Thunderbolt dock on a laptop.
So in USB-C, the cables are a component, right? They're active. They actually have a function for voltage to drive your cable. The cable can be E-marked, which means there's basically a small serial ROM on there. And he says, oh, I'm capable of 100 watts. The cable is now part of the equation.
Yeah. So the cable also negotiates with all the other bits.
It negotiates. He's in the middle talking both directions. And then if you want to extend that cable, he says, well, I can because I'm active. I have a power supply. I'm going to retransmit these things, start the the eye diagram all over again, if you want to think of it that way. And I can go another meter or 2 meters, whatever the spec is.
Yeah. Yeah, it's gotten pretty darn crazy.
So we've got a question. How is the EZPD connected to the config channel here? I'm not sure what he means by config channel, but let me show. Let me show random things. The EZPD has its own USB port right here.
Right.
And it looks like, in my case, COM48, because I've plugged in that many virtual COM ports while testing one of my customer products. And each time it increments the COM port, and you have to edit the registry if you want to start over again. Why is that important? Can you imagine testing something? You want to test something in production and you want to program an ESP32. So you send them a laptop, you send them the code. They plug it in, but you have to send instructions that says, okay, after 100 times, you have to reset the registry. It's like
that.
Yeah. So you have to script the registry reset and whatnot. So, but it looks like just a USB COM port, and it took care of all the negotiation with that. So I didn't have to.
What's that?
Pretty cool.
One thing you didn't mention, which I'm really curious about, the other little device with a screen there, the USB monitor, or what is that? Tell us what that is and how you're using it there. Because I've seen those around. Haven't used one.
So I'm using it here. You'll see it actually indicates 20 volts and 0.002 amp. Oh, you can't see. Let me zoom in.
I'm looking at you.
Yeah, you're looking at my backside.
So it's a power, it's a USB power analyzer?
Yes.
How accurate is that?
I don't know. But I don't know that I care, if that makes sense.
I guess you have to be careful to only use the type A's or the type C's and not both.
is that true? Could I convert from A to C? I don't know. I'll have to play with it.
You might be able to, because that's a typical charging sort of cable situation.
Yeah. So the one thing about these, I have a second one here that actually doesn't work on USB-C that I could get it to. And what happens is even the one on the bench, I have to plug it in, and if it doesn't work, I have to turn it around and plug it in again. And you go, wait a minute.
They didn't flip the they didn't use the mirroring on the connector.
Well, the monitor has to break open the CC lines. That's what a cable does. Is there's two CC lines and it breaks one of them open, and you're supposed to be able to adapt. The reality is the protocol analyzer is slightly illegal. It's not meant to be in series with the USB-C, so it can only work with one cable orientation.
Okay.
And I learned that by talking to Aria from Hackaday. I'm like, is this a normal way for this to break? And she's like, it's a normal break of USB-C. Yes. So cool. And if you want to know more about USB-C, head on over to Hackaday. And Aria Varanova's got a great series on USB-C. I'm actually using her things as tutorials for my journey into USB-C.
That's good to know, because what are the other resources? There's actually, that's something I was probably going to show. In spite of the cost of doing things, where is this? I'll open a new browser because I can't find the tab. Hang on a second. USB IF.
So while you're doing that, I'll just throw out that I've been playing with my Mr. FPGA this week, and I've ordered SRAM for it and stuff so I can play more than Pong. But for those that don't know what that is, you take a DE10 nano board made by Terra ASIC, and it can emulate almost any form of retro hardware, I think. So.
Oh, that's cool.
Yeah. So I'll definitely be showing that.
Yeah. So the point was, this is if you're officially building USB products, eventually you're going to come here, because this is the industry foundation. So this is the organization that defines the standards. The cool thing is, I think they only fund through issuing device IDs and product IDs and memberships, so you can influence the next version of the standard. But besides that, if you go to document library, you don't even have to sign in. You can. So USB power delivery test specification, Bill, this is relevant to what you're doing there, because you're specifically working on power delivery and handshaking. This is zipped, and it's 5.6 megabytes. So it's a pretty big document. But you can download the test spec. So if you're designing a new power supply and you want to be able to charge phones really quickly, or charge laptops in a more generic sense, you would need to test it according to this standard before they'll issue you with a PID or whatever stamp of approval to use the USB fast charging logo on the product. So yeah, I mean, there's a lot here. And that's, 4 is around the corner. The 4 standard was spec'd already more than a year ago, but not many devices are using it. Yeah, here it is. USB 4 specification version 2 even.
Right.
Came out in October. I'm going to download that. I need something to read on my nightstand in case I can't sleep. This will put me to sleep. So anyway, it's all there. That's the cool thing. Hey, you don't want to see my text.
And it's not like an IPC spec that you have to purchase.
Yeah, different trade organizations do things differently. IPC charge for every little thing. which kind of, in my opinion, makes it a lot less accessible and more likely to be shared illegally by people.
Right.
And then USB Trade Association, you can download everything, but if you want to use the logo and have an officially approved product, then you're going to pay for you pay a one-time
right
fee.
and I don't mind that. That's paying on the back end, but
it's not even that expensive. It's not
Yeah.
even that expensive. Some IPC standards, just the one document alone might be
$1,000.
$1,000, whereas you can get your own PID. You can get your own vendor ID, which
Right.
under which you can get multiple product IDs.
Right.
You can get a vendor ID for a few thousand if you're a member.
Right.
So
yeah, the problem I have with the IPC type stuff is it's like we want you to use our spec. It's a better world if you use our spec. You'll make better products, but we're not going to tell you about the spec unless you buy it. It's like, oh. So
yeah,
hey, so Worthington Assembly has on their website a spot they call it the perfect 0201 and the perfect 0402 footprint. And of course, they're not perfect, but they're really usable for manufacturing, right? And they just put up, I made them a set of footprints and they put them up on their website. So the footprints are in Altium.
Very good.
So if you're going like for 0201 or something.
I did previously have them in Eagle for download, if I recall. Because Chris, who probably wrote that blog, and I know Chris wrote the 0402 version of the blog, he was using Eagle back when that was done.
Right.
That's good.
So, and I
have
have
some KiCad download as well.
What's that?
Do they have a KiCad download as well?
No, but I've tried to get Mike Fikes to make one. So it may be that might be a
hard.
good exercise for somebody out there in KiCad.
It's super easy. It's just a couple of footprints.
Right. So it's for me, it's mostly having the confidence to share your work, right? Which is why I had you review my footprints before I gave them to Worthington. So it's
tell me. So you mentioned Mr. FPGA, right? Or
right.
DE2, DE0 Nano or D2?
DE10.
0.
Or is it a DE0 or DE10?
So this is something I should be, but I am not familiar with. Mr. FPGA. Tell me what that is.
Well, so my DE10 is upstairs. This is a DE0, I think. John, am I missing something? The DE0 doesn't have an HDMI output. So unless this is, I'm pretty sure this is a DE0. But the DE10 looks like this, only bigger. You just load a font, load a code on it, plug in your HDMI and flash some firmware. And it emulates Ataris and Apples and
I get it. So that's because I know about Digilent and all their generic sort of FPGA development boards they've had over the years. I've used quite a few of the different ones. So Mr. FPGA is someone who's made Commodore emulators or a series of emulators that run on that board. Right?
A whole group of open source people, and they did Atari and Apple and stuff.
Yeah. Okay. And it's open source, so like anyone can download it and go. I like that.
Oh, hey, I got Commodore news. Oh, so Jerry Ellsworth is joining. I'm sorry about this, Ben. I know you can't be there. Jerry's going to be there Friday, maybe Saturday, showing her product and stuff.
That's so cool.
So, what was I saying before that? Before VCF, well, I'll think of it in a second. Commodore News. So I go to make my T-shirts at Custom Ink, like I do every year before I go to VCF. I usually get a shirt that says, my computer has sprites, or what's dead may never die, or something. It's got the Commodore Chicken logo. And I got a Hackaday shirt, so because I'll be representing Hackaday a little bit. And Custom Ink kicked it back and said, you don't have the rights to these trademarks. And they're pretty much right. But they said, if you can get us proof that the people don't mind, you can have your shirts. So I said, well, look, I'm an employee of Hackaday, and I sent him to the link, the Hackaday/William Hurd link, and they go, okay, you can have your Hackaday shirt. So I email who they told me to, Clanto, and
Someone
I
in
say,
Italy. Someone in Italy.
It
Wasn't
Massimo. It wasn't Massimo. I know who Massimo is. I actually exchange emails with him.
Because was he the one that got all the Commodore trademark?
He thinks he did. Yeah, but it's not him.
Okay.
It's somebody else.
And they were selling Commodore with the chicken head logo and everything, phones.
On cell phones, right.
Yeah.
And they were just Chinese knockoff cell phones, right?
Yeah.
So I go to the website they sent me to, and I go, hi, I'm Bill Hurd. I used to work there. I'd like, to produce a couple T-shirts for my own use. And the email comes back, goes, hi, Bill, haven't seen you in a while. So I know the guy, right? And so I send the email to Custom Ink, and they go, you're right. He approved you can use Commodore on a T-shirt. So I'm now an approved Commodore T-shirt wearer. And I couldn't believe Custom Ink had a method for dealing with me as a person.
That's amazing.
Yeah.
Right,
yeah.
How many shirts were you asking to produce? 'Cause
2.
It's like, why would they even care?
Yeah. Yeah. But I suppose if the shirt had Nike on it, they would care.
Well, I guess they don't want to be taken to court by some
Right.
gigantic corporation that has deep pockets.
Right. And what's the difference between 1 and 10? Well, for copyright infringement, none.
Okay. Okay. If we wanted to do something with the logo and make merch for our Discord and our viewers, what would we need to do to get approval to do that?
Well, for Discord, if you had your own logo or whatnot,
no. If we, as let's say, Coriolis Effect did a Coriolis Effect T-shirt or something that had the Commodore logo on it, what would we have to do to make that kosher?
I don't know that I would ask.
Would it be the same person who could approve?
Yes. Yeah.
Well, exactly, right? So we would just ask. And
well, I wouldn't know, because I worked for Commodore, the real company. So that's them and I'm me. And that's why there's no Commodore logos behind me,
Yeah. Okay. I don't quite follow the logic there, but that's okay. I think that's an emotional decision, not a logical one.
Oh, it absolutely is. Yeah. Yeah. It's like I've defended the mark so long.
That's totally respectable, because, EQ is just as important as IQ. So
Cool. Hey, I got some new test equipment this week.
Oh, come on.
I did. My bench behind me has been redone. If you've watched me for a while, I've gotten rid of all the big HPs, mostly because they're old like me. And the bench was starting to sag. And
yeah, it was pretty heavy.
So here's one I got, and I got most of this from Mike Fikes, but Mike had gotten a Keithley 2000 by accident that he ended up paying for. And so I just bought it off of him. And so I got me 6.5 digits of sweetness. And I had to do it because my Keithley 195 was broken in the AC ranges. So now I have DC.
Good. That's such a nice meter, man. That's way up there in bench meters. 4-wire sensing. Come on.
Yep. So that's equipment acquisition number 1. Let me show another one.
Ready to sell?
Okay.
Oh, you got a counter.
I got an HP 53. What's
15? I had one of those.
Yeah. I got this.
I think the one I had was an older, lower end version of that, but I had one of those for a long time.
I got this from a source called AccuRental. I really like the guys there. Oh, so let me tell the story. My CSA 803, which last week's thing was on, Ben, you know this. I go, it's out of calibration. The battery died and all this. And bottom line is we got the battery charged, but I emailed the people, AccuSource, that I bought it from 5 years ago, and they sent me instructions on how to fix the battery. Right?
Oh my
I mean,
gosh,
they're
that's so
supporting
good.
it 5 years later. Thanks, guys. Thanks, Rich. Thanks, Joe.
So,
And so I bought this in return.
Okay. What kind of what kind of battery is inside that?
Well, there was 4 batteries, but they're DS1223s, the old Dallas Semiconductor socket.
Oh,
that's an SRAM and combined RAM.
Yep.
Yeah, because remember you did that once. You
right.
Tell your foil story.
Many years ago, I had so when I was in my last year of college, I was working part-time at 2 different places. One of them was an auction / clearinghouse. They were just picking up absolute junk computers from government and large companies like banks that were just upgrading whole departments. And so they had all these weird computers that previously were horrendously expensive name brand machines. Many of them were Memorex, Telex, PS2 clones, and they also had a bunch of genuine IBM PS2s in the smaller form factor cases that were, for the most part, 286 and 386 computers. A few of them were IBM PS2 clone, IBM PS2s. So not even isobus. These are microchannel architecture, right? The first official plug and play
microchannel. That's right.
These computers were so bizarre. Some of them had a 286. They had a 286 motherboard where the 286 had been in a PQFP. No, that's the wrong package. What's it? PLCC socket.
Oh, okay. Right. 286 and 287. Right.
You pull the 286 out of the socket and plug this little daughter board that would plug in over the socket, and it had a 486 SX
right
surface mounted on it as a quick and dirty upgrade. And my job was to go through and test them and try to get them to work, because most of them that they had CMOS backup batteries. And the problem with microchannel architecture was the whole configuration of the computer, all the addressing, all the interrupts, which card was which,
who registered, right? Yeah,
was all in the CMOS,
right?
And if it lost the battery, you had to reconfigure it. The problem was more than half of these computers were weird clone brands that weren't original PCs. They were apricots,
right, and
Memorex, Telex, and this auction house. They would just go and buy them by the pallet at auction, really cheap. And it was my job to go through and try and get some of them working. And they didn't have the original. You had to boot from a special configuration floppy disk for that specific model, or you couldn't write the CMOS, and you had to have associated floppy disks for any add-in cards in the microcontroller.
Right.
And so most of them were like, we could just barely get them to work, and they had add-in cards and things that were never going to work because we didn't have any of the original drivers, configuration tools. So those would come out and be put on a big junk heap, which would go off to recyclers. So anyway, one time though, like this Toshiba laptop came through, and I'm like, I'll take that one for me. And I paid the guy, and I got it for cheap. It was a monochrome TFT panel, like the really old kind that has terrible like latency. It was a 386 SLC, not even an SX, so even more cut down version of a 386. But it was a laptop, and it worked. But I couldn't get into the BIOS. The BIOS password had been set, and I didn't have no one had the password. So on my other job, I was repairing telephone typewriters for hearing impaired and deaf people. and I had this really killer rework station there. So I took the laptop in there, and I found inside it had that exact Dallas
DS1223 type thing.
Had the DS12. That was the CMOS. So I desoldered it from the motherboard. Everything else on the motherboard was surface mount, but this one CMOS chip was through hole, and I used the solder sucking gun, desoldered the whole thing, carefully pried it out of the motherboard, pressed it into some foam covered in aluminium foil.
That's aluminum for
aluminum for Americans. So dead short on the VCC pin.
Right.
Pulled it out, soldered it back in, and what do you know? The CMOS was cleared, and I could get in and set the thing up, and then I was able to sell it on eBay, and I made money on it. I was super happy.
And the battery was only a little pissed at you for the short.
It was just for a couple of seconds, and yeah.
So we had a problem. You know, I'm from the days when you made your own battery backup, and when the Dallas part came out that we're talking about, where they put a battery in a RAM, we had issues originally where we had batteries on boards, and we never stopped to think about what happens when it goes through the drag solder machine or the flow solder, and it shorts the battery out. So nowadays they have batteries that you first apply a voltage to, and then they'll turn on. It's like you're kicking the chocks away from the wheels.
Oh yeah. Or you would have to create your battery footprint in your CAD library with a mechanical layer note saying must be mounted like solder flow this direction.
Right.
And I've seen quite a few libraries back, not so much lately, but 10 years ago or plus, where they had parts where they actually specified solder flow this direction.
Right. Yeah. And we had a drag solder machine, which is not like a wave solder. You go over a fountain well, actually it goes this way and the fountain hits it. A drag solder machine goes into a big puddle of solder and drops into it and then kind of comes back out. So there is no direction because it does the whole board at once.
So
that shorts out batteries. Yeah.
That's going to short out anything.
Yeah. So very cool.
Wow.
Yeah.
We're past an hour again already. How's that happen?
Yep. So, well, cool. So, again, everybody, VCF, April 14th, 15th, 16th. I'll be there 14th and 15th. David Murray's going to be there, 8-bit guy. Usagi Electric, David's going to be there. Ben, you won't. I'm sorry.
I'm gotta see my parents.
Yeah, you gotta take care of family.
Yeah, otherwise I would have definitely made the trek out. I know last year I said, I really want to go next year. It's just timing isn't the best. So I will miss you all, and maybe I'll try and join some of the live sessions or something. If you're up, if you're awake, we can. And you'll be jet lagged, so you'll be awake. Maybe we'll do something. We'll see.
All right. Well, I want to thank everybody for joining. By the way, check us out at Coriolis Effect-effect.com. There is our Discord invite. Discord's been roaring again, so please join us. Please come talk to Discord. Ask questions. We make up answers all the time, so it's a lot of fun.
But our made-up answers are better than ChatGPT's made-up answers. So how about that?
Yeah, it's better than guessing, right? So very cool. All right. Well, good seeing you again, Ben. Good seeing everybody. Happy Friday. Happy what's St. Patrick's Day?
It is. That's right. I should have been wearing a green cap, but I
accidentally wore OD green. Yeah.
Yeah.
All right. We'll catch you next week.
Find an Irish pub somewhere and have a few.
There you go. They don't make enough beer for me, so I just don't go. I'll talk to you later.